Whoa, stop right there. Has this right here ever happened to you? If so, please try my new technology created for my Lab9 project, where it allows you to detect nearby objects with sensing and actuation with vibration motors. Hello everyone, my name is Donald Cash, and for my Lab9 project, I created a wearable obstacle detection device, specifically for visually impaired individuals, so that they become more aware of their surroundings. This inspiration kind of became from sitting in the back of a Tesla and seeing the assistive technology and the sensing that the vehicle does have. And my main objective was to create a system just like that, but remove the visual aspect and kind of just keep visually impaired people or provide users with environmental awareness through directional haptic feedback, or instead of relying on visual alerts. The system uses vibration motors placed right here on the back, connected with the alligator wires to kind of give more information on how close a nearby obstacle is. My project uses Arduino Uno as the main microcontroller, and I use 2 ultrasonic sensors to give that sensing and that directional obstacle awareness for said users, and they're positioned at an angle for more of a coverage and more of a range. One of the more important concepts that I did learn from watching the specific lecture videos and the specific in going to lecture was that we can't connect our motors directly to our Arduino microcontroller because that can create damage or different voltage spikes or different errors within our code or different failures. So I use the NPN transistor. As you can see right here, I use 2 of them because I have 2 different motors. And that allows us to switch between vibration settings within our motor. And through the Arduino output pin, I kind of use that as the base of the transistor to kind of initiate that output in that voltage signal or spike. It's a small signal that's kind of sends throughout the code. And on the positive side of each motor is our 5-volt pin, and I kind of try to color code it with the red and the orange and the gray and the black. Red and the orange is the 5-volt, gray and the black is the ground, and the blue is the connections to our Arduino pins. And I used a transistor. Oh no, I used the flyback diode across each motor to kind of protect the circuit from EMF, which reverses the voltage spike, and it kind of just helps the system be safer overall, and kind of keeps connected directly to what we learn throughout class of not just connecting our motors directly to our microcontrollers. So moving on how the system kind of works within my code, with the sensing, I kind of just initialize all my said components, like my motors, my pins, letting the distance be -1 if it is when it's out that specific range or target, and that sensing is within that range. So when it is greater than 50, a distance of 50, it kind of just is completely shut off, and then it kind of, once you go in that range of 35 to 50, then it's a small buzz, and then it's a little stronger buzz as you go closer and closer to our sensor to kind of give that haptic feedback to said user, who kind of just gets more of a environmental or surrounding awareness. I mechanically 3D printed and designed the sensor holders and the holder for the glasses and the holder for the OLED. Kind of just trying to emphasize on creating a cohesive design and trying to make it aesthetically pleasing as possible. Now I will demonstrate how my processing unit works. As I said, as you kind of get closer to our sensors, it will kind of just allow the user to understand how close the object is coming, and it kind of works like that on the same side, on the other side as well.
I only see my goals, I don't believe in failure, cause I know the smallest voices, they can make it major. I got my boys with me, at least those in favor.